Welcome. The topic of my talk today is a Python script for abstract dialectical frameworks. And abstract dialectical frameworks are a generalization of the famous Dung argumentation frameworks. And with these frameworks, we can have a sophisticated modeling, but the practical application concerning abstract dialectical frameworks is quite tedious because we require a lot of computation. And that's why we had the idea that we develop a Python script for abstract dialectical frameworks. So the user just need to specify the abstract dialectical frameworks and the desired semantics and get the output. And also we have found the class of single node formula, which are providing a faster calculation of the semantics for an abstract dialectical framework. And we have chosen Python because Python is a common high-level programming language which enables a simple implementation and also enabled it to implement the calculation of an abstract dialectical framework quite easily. So we could, for example, also find out and test the behavior of the single node formula. Okay, before we look into the script, a short recall what an abstract dialectical framework is. Basically, an abstract dialectical framework is a tuple where we have S, which is a set of arguments, also called statements or nodes, and each argument is getting an acceptance condition phi, and this acceptance condition is a propositional formula. So it's basically a logic formula. Concerning the semantics for abstract dialectical frameworks, essential here is the gamma operator, gamma v, where v is an interpretation, and the various semantics depend on the relation of an interpretation v and the interpretation returned if the gamma operator is applied to this interpretation v. And very short, the gamma operator works that we start with a 3-valued interpretation and consider the consensus of all 2-valued completions. And the consensus of these completions is the meet according to the following information order, which we can see here. So we can see that the value undefined is the value with the least informational value. And if we have two interpretations, v and w, it is a case that v is an information order relation to w if the information order relation is given for all nodes in our considered abstract dialectical framework. In order to illustrate the use of abstract dialectical frameworks, we have a little example. So it is the middle of the night and one wants to get home as quickly as possible. The only possibilities to get home are either taking the bus or walking. But unluckily, it is not known whether the bus will really run tonight. On the other hand, it is important to get a little bit of sleep that night, but this is only possible if the faster connection with the bus is used. In addition, the walking option is only preferable if it is not raining, but luckily it is the case that it is not raining this night. Okay, so we can model this situation as follows. Here we see our statements, And here, for example, we have the statement W, which means walking home, and the acceptance condition for the statement W is that it is not the case that it is raining and that I am not taking the bus. And the acceptance condition here, for example, for the node H, which means that one is at home, mean, okay, this statement is accepted if either the walking option has been chosen or the bus is used. So if we want to use our script right now, we only have to edit two variables. The variables nodes and choose interpretations. And in the variable node, we are entering our nodes and the acceptance condition. Each node is entered as a list where the first element is the node and the second element is the acceptance condition. The acceptance condition is entered as a string and as a logical formula. And in this acceptance condition, we can use, for example, the comma for a conjunction or the sharp for a negation. And also it is possible to use the question mark, for example, for falsum. And choose interpretations. There we can specify which interpretations we want to have. So we can, for example, just write A into it for admissible interpretations, G for the ground interpretations, or we can also write 3 into it, which will use a 3-valued logic. This will be considered in a few moments. So if we are looking at our getting home example, it looks basically this if we enter it in our script. So basically here we see the variable nodes, and here we can see all of our statements with the acceptance conditions, first entry statement, and here always the second entry is the acceptance condition. And for choose interpretations, here in our example, we want to calculate the admissible, complete, and preferred interpretations. And the output of the script looks as follows. So first, we are getting a formatted formula, which is a representation of the internal formula representation of the script. So it's just a signal to the user that the script is working properly, and then we see the desired interpretations. And here in our example, we start with the admissible ones. Okay, I talked about the tree option, and if the tree option is specified, then we can use a 3-valued logic, more precisely cleanest, strong 3-valued logic for the evaluation of acceptance conditions. So with the 3-valued logic, it is not required that the consensus of all 2-valued completions is considered. So we can use directly a 3-valued logic and therefore increase the speed for the computation. But the 3-valued logic can only be used if every acceptance condition in an abstract dialectical framework is a single node formula. And an acceptance condition of a node is a single node formula if each node which we have in our abstract dialectical framework appears at most one time in an acceptance condition. If we look back at our example, what we can see here, basically we can see that every acceptance condition is a single node formula. For example, let's look here at the statement B for bus. Is accepted if I am not walking and taking the bus. And as we can see, each node appears at most one time in this acceptance condition, and therefore, it's a single node formula. Now we asked ourselves this three-valued approach, how much faster is it in comparison to the classical two-valued completion approach? And therefore, we created a test case generator. So we generated random ADFs, yeah, which in amount of nodes. And for each node size, we tested 100 test instances. And some of the results can be seen here. So here in the first column, nodes, we see basically the amount of nodes which has been used. And RDM stands for the admissible interpretations. RDM3 stands for the use of the three-valued logic for the admissible interpretations. And speed says how much faster the three-valued approach is compared to the classical approach. So we can see if the node size is increasing, so if we are getting bigger and bigger abstract dialectical frameworks, then also the speed of the speed gain is increasing too. And here it is only illustrated for admissible interpretations. For the case of complete and preferred interpretations, it is similar. What can be seen here on the right side for the ground interpretations is that the speed gain is even higher. It's the highest speed gain which we found in all of our test cases. But this can be explained that the ground interpretation is calculated in a very special way. So we start with the interpretation which has the least informational value and apply the gamma operator iteratively again on this interpretation till a fixed point is found. And here we can also illustrate our interpretations. So we have, for example, so we can see here we have the admissible and the ground interpretations. And what should be kept in mind is that the y-axis here is logarithmic, so the time still grows exponential for both approaches. So in conclusion, we get a higher speed gain with an increasing number of nodes. And for the grounded semantics, we have the highest increase in speed if we use the three-valued logic, but the needed time for the calculation still grows exponential, and therefore the practical use for the three-valued logic or for the single node formula approach is limited. And for future work, we might want to enhance the user interface, so the user does not have to edit directly the variables in the script, and we want also to find some further ways to increase the performance of the script. Thank you.